Hello and welcome to another free code session. My name is Jason Bach and I'm going to continue addressing some IronBefunge issues. The first one we're going to do, or I should say the next one we're going to do, because I was continuing on from the last video, is this implement quit instruction. So the Q quit, and because I'm trying to move to funge 98, got to get up to spec, ends the entire program immediately, regardless of the number of IPs active in concurrent funge. We don't support concurrency just yet. I think that's on the list. It also pops a cell off the stack and uses that value as the return value of the funge interpreter to the operating system. Okay, so let's just find here the quit instruction. I think I just copied this. You can turn a full cell and you also turn, yeah, that's fine. So this one sounds easy, right? This is number 19, so let's get our branch going. 19, quit instruction. And we will publish this. Okay, so how do I want to do this? We have directional. It's not directional. It's not an input. It's not a logical or math, number, output, space, stack, turn. It doesn't really fit into any of those. And I don't want to just fit something in if there's no reason to do so. So, what will we call this? Environment instruction handlers. Because I think there's things like fingerprints that they call them, handprints or fingerprints. Concurrency might fit into this. Like that you want to launch a separate funge space. There's a couple of others, I think. So, and arguably input instruction handler would get into that. Input and output. I might, because these only have a couple, right? Yeah. It might be worth shoving them all into one. First things first, add new item, name environment instruction handler. Okay. So let's just make the one for what we're doing right now. Yes, you can all go away. You need to be implemented. You are going to be a quit instruction, which is a Q, and then we need to do this. Yep, you don't know what that is. And then we say environment instruction handle quit instruction. Okay, so then we come here, environment instruction handle quit instruction, and we need to ensure that there is something on the stack. Okay. So, how do we quit? There's no way to tell the context, like, that we're done. We need to be able to tell the context that you're done. Context values. Pop, and that'll give you an int, and that's what's going to be returned. There. Okay. So, in the case of a context being quitted, what we need to say here is some fun stuff. What I think I need to do, no. There we go. What happens when we get to, because this is the execution context. The interpreter, the executor, I don't know. The end program instruction is the @ sign. This handles the instruction. Arguably, I'm kind of curious. What's the difference between the at? So the quit is almost like an error, if I'm reading this correct, because you're popping a value off. And you could have, this just stops, yeah, if you have like a single threaded program, then yes, everything stops and you just exit. If you were stopping another funge space, the rest of the program may continue. That one is now done. That just stops that current one. Okay, that we'll come to that later. We're just handling this now as though it's a single threaded execution, which it is. So how do we say to this thing, you're really done. you're toast. You're done. Is it actually is it an instruction that should actually be even handled by the context? Because if it runs into it, it should just stop. I guess you could have something on the context that says, okay, I gotta think about this for a second. Where does it make the most sense to handle this instruction? It really has nothing to do with moving. Sorry, I had to think there for a second. The ensure stack comes from the context, which is fine, but the executor is going to need to know. It starts becoming one of these specialized instructions, but it has to be. It has to. Okay. I think what I want to do is make execute return an int. Okay. So right now, it returns a 0. Okay. Could do this. This is a little true. If yeah, being in string mode is also a good thing to keep in mind. So if the current instruction now is an end programming instruction and the context is not in string mode, you break. Yes, you break out of the while and you would return a 0. Else, we gotta do the same thing. If context current value is equal to executor quit program instruction, and you're not in string mode. That's also important. You need to say the context ensure stack is 1. And then we'll return by going to the context cells pop. Oh no, stack. I can't see the stack from where I am. Is it values? Yeah, okay, it's values, sorry. The values pop. You don't know what quit is. That's fine. We're getting there. Quit instruction, which is a queue. So really, this goes away. We didn't need this. Okay. End program is really not true. It's just right now we don't have a choice. This is a quit instruction. And we'll call this to be a little bit more consistent end instruction. Okay. So I have the feeling if I ever get to adding concurrency that my executor, like the concept of an execution context is going to be copy the execution context into a task, have it party on from where it currently is, and then have this just keep running. Okay. but I have to keep track of any child tasks that I did. And if I end, I have to wait for the other tasks to end. That would be fun to. And then also there is a task that I have, an issue that I have that needs to make the execution context immutable, which is going to be a little hard because you can see some of these are directly changeable by other things. And we really don't want that. So we can get rid of quit here because nobody's going to call that anymore. You know, what we really need to, well, either make it immutable or have a way to say, copy the current context into another context and have it completely like separated from the other context as much as it possibly can. Like it needs to have the same cell values. And this is also interesting because if you did another concurrent thread, could that possibly trace around to where you currently are and changing values there and then coming back here? Yeah, you probably could. So that actually needs to stay mutable, as ugly as that sounds. But it needs its own stack. So the stack that you have, that would need to be copied. But from that point on, it has its own thing. I believe that's how it would work. Okay, so you'd have to be out of string mode too to even be able to do that. I'm thinking ahead here, but I think if I run this, it shouldn't cause any failures. We should still have that. Correct. Okay, and if I run this, we get that. All right, so now what I need to do is go to my executor tests. And I need to have something in here. I need to have some way to test that. Well, cool. Actually, that does. Okay. Throws. This now doesn't become a throws nothing, is equal to 0. Because all of these are just simply exiting with no problem. Okay. Execute with trace, that's that. This is going to become that. There was some point when I was making changes on all this stuff that I was so thankful I had unit tests in place because that helped figure out what the problem was. Anyway, so that's great. These are all just checking the trace in the randomizer. What I really want to have here is I want to execute with quit instruction. Q. But what I want to do is number instruction handler. Yeah, that will push. So if we put like a 9, this should be equal to 9, right? Let's see. And it does. Okay. Execute with quote instruction and nothing on the stack. So what this should do then is just give us a 0. Because we're ensuring the stack, and the ensure stack just pushes us no. Run the test. And that works too. Okay. Now, we've got that. That's great, but I don't think we're handling it in the interpreter. So the interpreter here, when we get to interpret, that also needs to return the execute. Okay? And in our host program here, we need to do that. So we need to say var result is equal to 0, result is equal to that, and then we say return result. There we go. Okay, so that's actually going to return the value. So now if we do this, this shouldn't really matter with the py program. Yep. Oops. I don't even know why I'm doing this. Now that I think about it. And then can I just say here, return, get rid of that, get rid of that. Yeah, I mean, it looks a little dirtier with all the crap that .NET puts in it, but, you know, it is what it is. Okay, so that actually does that. Stop with the temp files, Jesus. Okay, interpret null file. This should also now start doing is equal to 0. Grab that. Put that there. And these are just not calling interpret. We don't care. All right, so let's run all the tests. Passed. Passed. Okay. Added quit instruction. And because it absolutely refuses to stop putting these damn temp files in here all the time. More temp files. Okay. So we go to master, do the dance, merge into current branch, 19, merge, push, and come back to that, branch delete, delete on the branch, there we go. Come back over here, go to quit instruction, we should see that, oh, I thought I put the, I thought I put the hashtag in, but I didn't. Oh well. That's all right. Excuse me. Because we know, if we look at the executor, that we have the quit instruction. We are a master. Okay. Close issue. Boom. All right, so we got that done. 22. It's issue 22 at my time of being 22. Okay. There's also just a tick quote thing at the back tick. Fetch character instruction. This pushes the funge character value of the next encountered cell position plus delta onto the stack, then adds a delta to the position like trampoline, skipping over the character in no ticks. For example, the following two snippets perform the same function, printing a Q. So you'd be in string, you would push a Q on, you'd be out of in string mode. And then the comma, if I remember right, that actually prints, right? So if I look at output instructions, the comma takes whatever is on the stack, which in that case would be a Q, and prints it out as a Q. Okay. So then adds a delta to the position. Like, is that trampolining? I can't remember. trampoline instruction. Context, it moves to the next available. Oh, I see what it does. Okay. Oh, so we could use move. I'm still a little confused by this. Fetch character. This pushes the funge character value of the next encounter. Then adds the delta to the position. I don't think I'm going to handle this right if I just like assume, because I don't know if I'm actually keeping track of the delta. Yeah, I don't even know what that means. That's the context. Do I do that in the executor? What does a trampoline do? Moves the IP1 position beyond the next funge space in its path. Yeah. So, what does that mean? So, if I see the tick, I need to move, get the next one, push that onto the stack, and then move again. And then it would get the next. The comma would actually print it off. Okay. I think I understand what this means. I think. What I am wondering, though, is, like, what would this actually end up being? The in-string mode actually happens outside. That's in the execution context. We do that on purpose because if we would see a... You know what? I'm starting to think that the executor shouldn't have to know about in-string. Like if I got a handler to say handle the instruction and it saw that it was a double quote, it would just say flip in string mode. The problem is if I do that, then every instruction has to what I could do is say, if I am in string mode, then I do this. Then I do this. Okay. Otherwise, I just do this. That takes this out of the picture, and I think that would work. Okay, but we're almost at time. So I think what I'm going to do is create kind of that environment handler and move the input and the output instructions there. And then we're going to push the in string mode that into there and let it handle that by just flipping that. I think that's the right way to do it. So we're going to do at least another one. So thank you all for watching. Leave comments and questions below. See you in the next episode.